Hi, this is Liang, and the net ID is sl5352, and I'm doing this probability and stochastics homework 6, and this is the solution to question number 2. Here's the question. Given that x, y are independent with exponential densities, and here's xy, fx, and here's fy, and find the joint density, which is z equals to x plus y, and w equals to x over y. This is a very kind of like classical using the question using the Jacobian matrix to solve that. Two random variables, two functions to that, and to find a new joint density function. So first things first, we need to write down the Jacobian matrix, and to write down the solution to this. Kind of using the xy, using the zw to express xy. Here we got our solution here. For xy are independent. That is one of the very important criteria we need to use later on. So follow the steps. We need to write here some Jacobian, right? Oh, hang on a minute. I'm sorry. Why I'm saying that the xy independence is so important because we don't know the joint density function before. They're not offered directly, but they're independent, so we could write it as an fx times fy, which is pretty easy later on, and we write them still using the xy form, and then we plug it in by using the definition region. Also plug in the definition region with an x is greater than 0 and y is greater than 0. So we plug the xy in, we could get this one. And the definition regions here. Because I do the little bit how should I put it? I do a little bit just calculation about the just limitation about the x, the z and w. For w plus 1 is greater than 0, which is here. I firstly look at come on, firstly look at what here is greater than 0, and yeah, I firstly looked at the x. For w plus 1 is greater than 0, which is the denominator is greater than 0, so the numerator should be greater than 0 also, and thus lead to z is greater than 0, and w, which is from here, is greater than minus 1. Yeah, and yeah, from the z is greater than 0, so z is greater than 0, so we need the dw greater than 0, so w should be greater than 0. So here we got a w greater than minus 1, w0 greater than 0, so thus yield and final regions of limitations that w is greater than 0. For the next situation that the w plus 1 is smaller than 0, which is here and here. So we need the z is smaller than 0, which gives here, and z times w is smaller than 0. These gives us a kind of like a clue that w from here is less than minus 1, and from here z is less than 0, so z times w is also less than 0, so which need that w is greater than 0. So that leads to w is equals to phi is equals to empty set, which is doesn't exist. So the final solution region for w and z is they both greater than 0. This is the solution to this question too. Thank you.